Hello students, in this video I will be explaining how to use a t-distribution table to solve a problem of hypothesis test for the mean. In this problem, the standard deviation, the population standard deviation is unknown. The problem says, according to a study carried out 10 years ago, the average wireless phone user earns $32,400 per year. Suppose the researchers believe that the average annual earnings of a wireless phone user are different now, and he set up a study in an attempt to prove his theory. He randomly samples 18 wireless phone users and finds out that the average annual salary for this sample is $30,900 and the sample standard deviation is $3,600. We are going to use a level of significance of 0.10 to test this researcher's theory. Assume wages in this industry are normally distributed. So we are going to assume this. And this will be a two-tailed test, and I will be telling you why. Let's get a solution of this. The first thing that we need to do is to check what we are going to test. And we notice here that they're telling me here that I'm going to test the researcher's theory. And the researcher's theory is that the average annual salary is now different. The researchers believe that the average annual earning of a wireless phone user is different now. So for that reason, I know that what I'm going to check is that the mean is different than 32,400. This will be the research hypothesis. We are going to see if this is true. The opposite of this, if this is not equal, the opposite of this, it will be equal. Anytime that the hypothesis has an equal, it will be a null hypothesis. So the null hypothesis will be mu equals 32,400. The alternative hypothesis tells me that mu is different than 32,400. This alternative hypothesis is what indicates if we have a two-tailed or a one-tailed test. And in this case, because the alternative hypothesis is different than, then this will be a two-tailed test. A two-tailed because being different, being not equal, means that could be more than one tail or less than, that will be another tail. So when we are defining a rejection region, we need to take into account more than and less than. So for that reason, when I use the distribution, I will be thinking in two regions. The more than region, it will be the right tail, and the less than region, that it will be the left tailed. And because the standard deviation is unknown, I will be using a t-distribution. So this is not the normal distribution, that will be the t-distribution. And there are several t-distributions, but this t-distribution will be the one that have 17 degrees of freedom. Why 17? Because the degree of freedom is n minus 1. In this case, n equal 18. The sample size is 18. Then the degree of freedom is 17, one less. And these two regions here, far away from the center, will be the rejection region. So alpha equals 0.10 that they told me at the beginning. They said I'm going to use this level of significance. So that will be the area that is in the two tails of this distribution. So this is 0.10. So this will be 0.05. This one here will be 0.05. That is the moment in which I'm going to use the t-distribution table. Because the t-distribution table is going to tell me what will be the value here that separate the acceptance regions, that is the one in the center, to the rejection regions, that is the area in the tails. So I'm going to compute a t-test. If this t-test is too far away from the center, I'm going to reject the null hypothesis. Is this too big? It's because it's not the one in the center. Is this too small? It's because it's not the one in the center. So that's what I'm going to do. So I'm going to check if the t-test is here. But first, I'm going to find the critical value. See this value here that separate the acceptance to the rejection region. And for finding this value here, I will need a table. Assume that we need to use a table. We don't have a software. Let's open the table, and this is the t-distribution table. Usually it's like this. It has 3 rows at the beginning that help me to solve problem of confidence levels, or maybe a one-tail test or a two-tail test. There are some, so for example in this problem it's a 10%, 0.10 two-tail test, so I will be using here in two tails this 0.10. I know that there are some tables that doesn't have these 3 lines. Maybe they have just the confidence levels, 0.9. But I know if in the center, the confidence level is always in the center of the distribution. If the center is 0.9, then the 2 tails at the side will be 0.10. So if the center is 90%, the tails will be 10%. And obviously, if the 2 tails is 10%, only one tail will be 0.05 or 5%. So sometimes you can find tables that have only 1 line, and that's enough. But usually the table have 3 rows at the beginning that show you what will be the areas related to confidence interval, what will be the areas related to a one-tail test, and what will be the areas related to two-tail test. That will be at the top of the t-distribution. In the first column, we have the degree of freedoms. So for example, in this problem, we have 17 degrees of freedom. So the degree of freedom that I'm going to use is this. So in this line will be the t-distribution I'm going to use. So here, this table gives me areas related to several t-distributions. But the t-distribution that I'm going to use is the one that is here, in the row related to the degree of freedom 17. And because this problem is a two-tail 10% significance level, so 0.10 is alpha, so I'm going to use this number here, 0.10. So the value of t will be the value that is in this column related to this 0.10 two tails, and this 17 degrees of freedoms. So it will be this number. Yeah? So this row and this column, it will be this number here, 1.7396. This is my critical value. This is my TC. I'm going to call it T sub C. I know that some textbooks call it T alpha, some T alpha half. But whatever is the name, this is the critical value taken from here. This is the value that separates the acceptance regions to the rejection region. So this 1.7396, if I go back to my graph, this is this value here. This is TC, 1.7396. If I make a computation of the t-test statistics, and I get here at the other side, I will be rejecting the null hypothesis. If I get in this area here, I'm going to accept the null hypothesis. Obviously, the t-distribution as the normal distribution is a symmetric distribution. At the other side, if this is 1.7396, this critical value, we have another critical value here, negative 1.7396. So the negative of the one that is in the table is also a critical value if we have a two-tailed test. Because obviously, again, if the number is too small, it will be different to the number that I suppose true. The number I suppose is true is the one that is in the null hypothesis. I'm supposing that the mean is 32,400. If I compute the t-test to this number, the answer will be 0, and the 0 is in the middle. So now that I have defining the rejection region, I know what is the acceptance, and I also know what is the rejection. The rejection will be the values that are bigger than this 1.7396 or maybe lower than this negative 1.7396. The values that have a t-value, the t-value that have this. So I'm going to compute the t-value. This will be my test statistics. This is another step of the hypothesis testing. First, we need to have what is the null and alternative hypothesis. Second, we need to define the rejection region and the acceptance region. And then compute a test statistics. If I don't know sigma, the population standard deviation, what I'm going to use is the t-test statistics. So I'm using the t-distribution, and I'm going to use also the t-test statistics. The t-test statistics say that t equals the mean, the sample mean, minus the population mean, and this population mean is the one that I am assuming true. I'm assuming that the null hypothesis is true. So I am assuming that mu equals 32,400. So this is the one that I'm going to put here. Always the mean in the null hypothesis. And that's the reason why the null hypothesis always have an equal signs. In this case of the problem, they told me how much is n, they told me how much they got in the sample. In a real life, you actually need to decide how many elements in the sample. You need to compute the sample mean, and you need to compute the sample standard deviation. In this case, no. In this case, they already told me that the sample mean, the sample average, is 13,900. Let's take note of this. The mean is 30,900. They tell me that the average annual salary for this sample is 13,900. And they also tell me that the sample standard deviation is 3,600 and that n is 18. So we have all the values that we need to put here. We have the mean, we have the standard deviation, and we know also the sample size. Mu equals 32,400. So let's substitute each of these values. 3,900 here, mu equals 32,400, and this is 3,600, the sample standard deviation, and n equal 18. Use a calculator. I have already done this in a calculator, and I get that this value is negative 1.768. And now I need to see if this value is in the rejection region or is in the acceptance region. It's negative, I know that it will be to the left, and it will be negative 1.77 almost, yeah? And this is negative 1.73. Oh, definitely is at the left of this. This value will be here, negative 1.768. Is in the rejection region. Because it's in the rejection region, we reject the null hypothesis. Because the test statistics falls in the rejection region. So we reject the null hypothesis. And if we reject the null hypothesis, we are accepting the alternatives. So we are accepting the research hypothesis. So we can conclude that there is enough evidence, enough statistical evidence to conclude that the annual salary of the wireless phone users is different now. It's different than this 32,400. So that's the way that we work a hypothesis test if we have a table. When the sigma is unknown, and when we have a two-tailed test. In another video, I will be solving a problem in which we have only one-tailed test. But so far, for this video will be enough. So that is my explanation of how to solve this problem. I hope you have found it useful. Thank you and see you in another video.